And before I totally leave graphs, there are two kinds of best fit curves. Now this looks like a line and it is a line, but a line is also a curve. There are two kinds of curves you need to recognize by their shape. Two kinds of curves you need to recognize by their shape. Okay? And this straight line with a positive slope, this straight line with a positive slope is called a direct relationship. Direct relationship. Okay? And what is the formula, the algebra formula for a line? Y equals mx plus b. That's what you say it? Okay, how you say it? Okay. So what is the m part? Okay. And what is the b part? The y-intercept. Okay. So in most of what we do in science, there's no y-intercept, so it becomes 0. Okay. Now that's not always true, but most of the time we don't have we don't need a y-intercept because our origin is always going to be 0. That happens. It's different sometimes, but sometimes it's not. But most of the time, that's what it's going to be, a 0 intercept. So that b part just disappears. Got that? All right. So if we have y equals mx plus b, okay, and b is going to go away, we now have y equals mx. And if I want to know what m is, then it becomes y over x equals m. And what is y over x? Well, it is a fraction. Sure. Well, what is, No, what is m? M is the slope. So y over x must equal the slope, right? And you've learned to calculate slope by taking y1 minus y2 over x1 minus x2, right? Okay? But y over x is the slope. Okay? And so most of the algebra type problems that we have in science will fit this sort of form. Okay? There are lots and lots of those. And usually the slope is a constant in a science formula. So let's say volume over temperature equals a constant. That's one of the ideal gas laws. Okay? And you need to know that when I see something like that, hey, that should make a straight line. Does that make sense? And here's why. Is anybody lost now? Have I left you in the dust? K is a constant, but on a graph, K becomes your slope. 9 times out of 10, when you graph something, some actual data from the natural world, science, K is the slope of the graph. That's the constant. Does that make sense?
Why is it K?
Well, because that's the symbol that scientists have agreed on as being the constant. Symbol for a constant. Okay? Nothing special about it except that in math you want m because I don't know why they use m for the slope. Why do they use m for the slope? K is the first letter in the German word for constant. I don't know. Oh. I mean, I think who's taking German? Am I right? Oh, yeah. Am I correct? Is it the first letter?
I don't know.
Okay.
I believe you.
Well, okay. You believe me whether that's true or not? Okay. All right. Okay, and there's one other kind of curve that you need to recognize by sight and know what kind of formula, what general type of formula fits it. Now remember that straight line is always some y over x equals m, or, in this case I can say y over x, let's do this again. Y over x equals some constant. And that's a general form of a type of graph that you're going to see in the sciences, and it relates directly to this. Correct? Got that? Okay. And the other type of graph that you need to recognize on site as representing a certain type of mathematical formula, a comparison of data, is this inverse relationship. Okay, this is an inverse relationship. Now, if we were to continue this curve forever and ever and ever and ever and ever, it would never actually touch this x equals 0 line here. And this would never actually touch this y equals 0 line down here. Okay? And so you can take it out as far as you want to and you still get this same shaped curve. Alright? But this is an inverse relationship. Now, an inverse relationship has a general mathematical formula where x times y equals some k. X times y equals some k. And we won't get to gas laws until I think it is unit 6 or 7, but this is called Boyle's law. Pressure times volume equals k. Okay? Now you don't need to know that right now, but I'm just telling you. Okay? So you just know that you're going to see it, and you will recognize that's an inverse relationship when you see the shape of the graph or when you see the formula. You got that? Any questions about that? Does that seem especially hard? Kind of seems like something you've seen before in your algebra class, right? Okay. Now this one doesn't show it so much because all the markings are kind of big, but this is a best fit curve too. It doesn't actually cut the line, cut the points. It's just so close to it, you really can't tell that it's off those points in it. Any questions about that?
So that number will always work. Like
What's that?
X times y will always equal the slope.
Well, in this case, it's not a straight line.
So
But in this case, yes, that is essentially the slope for this relationship.
then what is k in the inverse relationship? Is it just a constant?
Why is it inverse? Is that the
I'm
question?
saying if it's an inverse, like for the inverse one, like you said k would be the same as equaling the slope, but why doesn't it equal that in the inverse one?
Okay, because on a curve like this, slopes have to be instantaneous. And so, what do you call that? A tangent? You need the slope of the tangent. And we don't pretty much deal with that in here a whole lot. Does anyone know what a tangent is?
Yeah.
Okay. So you can, huh? You taking geometry?
No, I'm in calculus.
Oh, in calculus. Okay. All right. So what do you do? What are you squirting? That's not a bad thing. God. Okay. So in order to know the slope, you have to pick a particular point on the curve to know what the slope is. You can't just say the slope of the whole curve.
So are we going to learn how to do slope?
No, that's beyond the scope of the class. Okay? But I'm just trying to tie it somewhat into the things you already know. So when you take calculus, and when you get to a tangent, you kind of know, oh, that's an instantaneous slope. Oh, yeah. Okay? Have you used the terms instantaneous slope? She's not listening to me over there. Have you used the term instantaneous slope in calculus?
Oh, yeah.
Okay.
What about
Good.
Good.
Good. And we do that a lot in chemistry, but we don't do it in chemistry 1. Okay? Instantaneous slopes are done when you're trying to figure out things like rates of reaction and things of that nature, and we don't really get into that in chemistry 1. We pretty much stick with this kind of simple sort of stuff. Okay? All right. I probably should have had the next section of unit handout, but I was kind of waiting until after this safety test tomorrow. Stop the capturing here and